Hello, everyone. My name is Hyun Nam. I'm currently associate professor in a CEC department. Since 2011, I have been working at UCF. Today, what I'm going to present is a sinkhole and subsidence detection, characterization, and engineering. Let's go. And here's a short overview of my work. My major research areas include the sinkhole and subsidence, natural and man-made, and then geotechnical engineering, and also civil infrastructure materials. Some of you guys in the college might consider me as a cement and concrete guy. Yes, I'm working on the concrete as well. But today's presentation is mainly focusing on a sinkhole and subsidence. Teaching more like geotechnical soil-related courses and also material-related course. And also I'm teaching the pavement engineering in a graduate course. And the contact information here, any questions, any email, and also here's my website, and there is a full list of the publication if you have more interest in details. And key achievement among those, and one thing I'd like to point out, I'm currently the faculty advisor of the ASE, American Society of Civil Engineers, UCF student chapter, and in 2016. I am proud of the award, faculty advisor award, and also to me, the most key achievement is my student. And here, I just listed the PhD students at UCF, and many of them are currently working in the university as a professor. So, I always meet them in a conference and workshop. We share the idea and we propose the proposal and a publication together. And here is the motivation. The goal here to predict and diagnose and mitigate the sinkholes and subsidence hazards so that the communities remain safe, resilient, and sustainable. So you see the photos of sinkhole here, and the one I'm showing you, this is a Winter Park sinkhole, 1985, the biggest sinkhole in the United States history. You see that the impact of the sinkhole here. Also the sinkhole on the road. So what if the sinkhole on interstate highways? So of course, the structural damage, but also there is a consequence, right? The congestion and traffic jam and do-do-do. And also here's a building damage. A couple of years ago near Disney World, and there is the Summer Bay Resort collapsed completely. And also these are two photos, not natural sinkholes. So these are anthropogenic sinkhole in urban area. About a week ago, near Seoul, there was a big sinkhole about a 10-meter diameter. I tried to point it out here. Nearby, there's the high-story buildings and apartment, and also this one is in a sinkhole in Japan, and there was a huge impact. And also one thing I'd like to show you here, there's a San Joaquin Valley in California. So there was a huge subsidence settlement from 1925 to 1977. There was a total 9 meters subsidence due to human activities such as land development and groundwater pumping. So that was a subsidence. So sinkhole and subsidence is global problems, sure, and natural sinkhole is a crisis everywhere, and also infrastructure. Due to aging of infrastructure, we have these significant hazard and collapse. So it is existing and a near future problem to us. And so this is a short overview of my research, and I classify as 4 categories here. The first one here, physical, and here numerical modeling and simulation. So we developed the sinkhole simulator, and here's soil, and there's let the water flow and then cavity growth. So we can video record and evaluate the behaviors of soil and the groundwater flow. And this is a numerical modeling, finite element modeling, and then we can quantify what is the impact of the sinkhole, such as a settlement, what is the influence zone. And the second one is site characterization. For example, cone penetration test and the probe, push it down to the soil and then measure resistance of soil. And that data, that information we use for engineering assessment. So we have other, testing device. We are collaborating with the Florida DOT. And the one here, that is sinkhole hazard map. So here the regional scale GIS based map, and we can predict the probability of sinkhole. And the one here, the GPR, ground penetrating radar, and geotechnical geological application, and also this the device, TPAD, as for sinkhole detection. This device belongs to a UT Austin, but I'm still collaborating with my advisor there. And another one here is those sensor, piezometer sensor installed, embedded in soil, then we monitor it. And so this is the current focus of my research is remote sensing, such as a LiDAR and INSAR, and then we can detect the sinkhole and predict. So those are short overview. Let me share a little more details, two projects here. One project funded by Florida DOT, and this is a very engineering method focused development of a sinkhole vulnerability evaluation program. Before, there was no such a systematic or practical engineering method. It's more likely, engineer collect all the data and then lay on the table and, based on his experience and judgment. So we came up with the tools and method with the three method approaches here. So here, the Raveling chart. So you see that here is a truck. We call this penetration test, and with the field testing, and based on the data, and we could develop the chart using the statistical analysis. And you see that there's a zone, severe, moderate, and mild. And once we push the probe, then collect the data and project it on it, then we see how many data points in each zone. So this is one way we can practically quantify the vulnerability of the sinkhole. And also here you can see that there's a formula. So we developed the index, engineering index, we call the sinkhole resistance ratio. So once we have the testing based on data, we can quantify the vulnerability of the sinkhole. And also another tools here, the finite element method modeling we set up, and you can see that what is the basically we can see the mechanical behavior such as stress and strain and also settlement, and also we can see the here is the influence zone, and also based on the scenario based simulation we can understand the mechanism as well. So those are more likely engineering tools and method focused. And now the multiple subtopics I put together, and sinkhole detection, prediction, and monitoring. So through the several funding agencies, NSF and Terracon, which is industry, geotechnical consultant, and also foreign country rural development administration from Korea, and we're collaborating with Dr. Wang in the department. And this is we call spatial size model, because size of the sinkhole is quite important, right? The half meter and a 3 meter of sinkhole size is the impact is totally different. So the one here is the regional scale, and what would be the probability of the size, and what would be the probability of the sinkhole occurrence. And the one on top here, there was a sinkhole gypsum step, the mining site, and once the sinkhole form, then from the surface to the groundwater, so that there is a direct path. So the surface contaminant, the gypsum is a radioactive material. Then what would be the impact from environmental viewpoint? So we model it, and from the site to the distance, so what would be the level of impact? So that was the funded by NSF, and collaborating with the Dr. Wang, and also the LiDAR data. And we use the LiDAR data and process it, and then we identified unreported sinkhole. And also once we identify sinkhole, then we can quantify the geometrical information such as the size and area and the slope and things like that. So that LiDAR, and now we are expanding to INSAR and also the AI. So here is my short term, which is a near term over the next 2 years. And of course, on top of the current studies, practical tools and software to help the engineers. And then I want to focus on the 2 areas. One is remote sensing. Okay, we initiate the LiDAR, and now we are working on the INSAR. So interferometric synthetic aperture radar, and that would be a really beneficial. Then now how to analyze data. So we want to apply the AI methods such as machine learning and deep learning, and So, and also the data for sinkhole and subsidence. So far, we have been investigating natural factor, but there's anthropogenic factors such as urban development and groundwater clumping, and also the social impact we can include it. So the data would be extended. So that will help to extend the sinkhole and subsidence research to risk analysis and management in this area. And of course, we need the national visibility, NSF, the several programs. I'm gonna submit a proposal sooner or later. And also the build up the industrial partnership. One thing in mind is I'm gonna initiate the statewide workshop led by UCF and invited a geotechnical consultant and build up the collaboration and partnership. And the long term here, we used to have the Florida Sinkhole Research Institute, but not anymore. But we have group focusing on the sinkhole. So we want to revive Florida Sinkhole Research Institute. Why is that? Because the name is out there. Nationally and internationally, the people in this area, they know the Florida Sinkhole Research Institute. We want to, why not? I mean, we want to use this name then. And there's a lots of facility and resource we can get from through the continuing collaboration, and also the Florida Sinkhole Research Institute will help to improve our education mission. So here at UCF, we don't have a Department of Geoscience, and the Florida Sinkhole Research Institute can make a big contribution on that because a sinkhole is a multidisciplinary, the geohazard, geochemistry, geology, and hydrogeology, and there's engineering and do. So we can do, so this is one example. We went to seminars, science competition and science affairs in elementary and middle school. So, and also the sinkhole simulator, you can see that how it behaves, and we have visual access. That is a good tool for education. And right now there is no, there are several geohazard centers funded by NSF, but there is no sinkhole and subsidence center. I believe that would be one of the target area sinkhole center proposal in the future as a long term, and also continue to develop the collaboration. That's my long-term plan. Here's my group, and so many thanks to my students and collaborators, and also department and colleagues, and also visiting scholars. So visiting scholar come over, and we regularly meet and develop the ideas, and so I appreciate for their help as well. So thanks for your time, and any question I can answer.